Today's lesson, we're going to work on solving these quadratic equations, and we're going to use a method called factoring, which you already know about because we just spent 2 chapters factoring. Basically, the rest of our chapter, chapter 9, we work on solving the quadratic equations, and we're going to learn 3 different methods to do this, and the first one is factoring. So in math, there is this helpful property that allows us to solve using factoring. It's called the zero product property, and basically it says that if you multiply 2 values together, so if a times b, if that equals 0, the only way to get 0 as an answer if you're multiplying 2 things together, that means that either a has to equal 0 or b has to equal 0. So that is what we keep in mind when we solve by factoring. So here's 2 examples. If you notice, they already are factored. So once it's factored, how do you solve? This actually will look a little bit familiar because we did some of this in our last chapter, but now we're going to really focus on this solving. Once your equation is factored, you take each factor and we write these mini equations. X minus 3 equals 0 and x plus 7 equals 0. Then you solve each equation for x. We would add 3. So x equals a 3. You would subtract 7, and x equals a negative 7. So those are the 2 answers we get from solving from the factored part. Basically, someone had already factored for us, and we went ahead and solved. So because we're multiplying the 2 factors together and we're getting 0 as our answer, that means the x minus 3 must be 0 or the x plus 7 must be 0. So we create those 2 equations and solve. Alright, our next example, it's already factored for us. So one factor is x, the other factor is the x minus 5. So there are your 2 equations. The first one you set equal to 0, and the second one you set equal to 0. Now x equals 0, that's already solved for x, so that one is done. X minus 5 equals 0, we're going to go ahead and solve for x, so we add 5, so x equals 5. Basically, well, I'll talk about that in the next slide. Alright, so we just solved for x. Alright, so when you solve an equation by factoring, you can see that this is our quadratic equation. We've been working on this chapter, x squared plus 7x plus 10. When you solve for x, you basically are finding the x-intercepts of your graph, or those zeros of the graph that we learned about. So first it says solve by factoring. So this is a trinomial without a number in front of the x squared. So you're going to take factors of 10 that add up to 7. So if we think factors of 10 that add up to 7, we get 2 and 5. We're going to go ahead and factor this. That turns into x plus 2 times x plus 5, and that is equal to 0. Now that it's factored, it's going to work just like the last slide. You set each factor equal to 0, so x plus 2 equals 0, x plus 5 equals 0, and you solve. So we get a negative 2. This one we subtract 5, and we get a negative 5. Done. If we were to graph this equation, these would be the 2 numbers that cross this. These would be the spots where your graph crossed the x-axis. Alright, we're going to try a couple more. So if you notice, this is not in standard form. You want everything on the same side of the equal sign, and I'll go ahead and throw out there that it's very helpful if your x squared term is positive. It just makes it easier for us to factor. So we're going to subtract the 4x from both sides, and when we rewrite that in standard form, we have 3x squared minus 4x plus 1 equals 0. That equals 0 is important. That's what allows us to do the zero product property and solve. Alright, so now we have to factor this. We do notice that there's a number in front of the x squared. So for the few of you guys that guess and check, please guess and check this. For everybody else, I'm going to go ahead and just review the A times C method. So A times C, you do 3 times 1, which is 4, and factors of 4 that add up to -1. Well, the only factors of 4 are 1 and 4 and 2 and 2, and if we made those negative, so they multiply to a +4, none of those add up to the middle term of -4. So I'm going to say that this is probably a bad equation. I can't figure out what we did wrong, so we will cross this one off. Sorry about that. Hopefully our next one will go better. All right, so let's just move on to the next one. We have to get everything on the same side, and we notice that we have a -3x². If we can get that to the other side, that will become positive. So let's go ahead and add 3x². So 0 equals 3x² plus 18x plus 27. All right, so what's really helpful to keep in mind when you do this factoring is, do you possibly have a GCF? Is there anything or any number that can fit into 3, 18, and 27? If there is, let's go ahead and factor that out. In this case, 3 does fit into all of those, leaving you with x² plus 9x, nope, not 9x, plus 6, oops, that wasn't the eraser. No, it's not going to let me erase. All right, that's a 6 plus 6x plus 9. All right, so now we can factor our trinomial on the inside. Because we factored the 3 out, it gave us something easier to factor. So factors of 9 that add up to 6, and hopefully we're getting a 3 and a 3. So x plus 3, x plus 3. That 3 is out front and it is still equal to 0. All right, so now to do that zero product property, we've got these 3 factors happening. You've got the 3 out front, the x plus 3, and the x plus 3. Now, here's what I'm going to tell you about this 3 out front. Because it's a 3 and it's not a 3x, there's not an x with the 3, we actually don't care about that 3 in terms of solving for x. We could do some math to get it to the other side, but in the end, it just doesn't change our answer at all, so I choose to just ignore it. I'm going to work on the factors that do have an x. So x plus 3 equals 0 and x plus 3 equals 0. Now, I'm writing down more than you guys probably would need to. Hopefully you've noticed these are the exact same equations, so really just solve one of them because you're going to get the same answer either way, and we get x equals a -3. So this equation has only one x value when we solved, which means there's only one x-intercept. So what would this look like on a graph? Over here at -3, this is just a sketch. This is where your vertex would be because we only had the one x-intercept. And we know it would open down because our a value is positive and all that good stuff. Alright, so here's our last slide. We're just going to kind of see how our x-intercepts help us out with our graphing. So we're going to go through the same 3 steps that we started out with graphing, but you can see that we are adding the x-intercepts. And we're going to make sure that this all fits in our graph. So x is of symmetry. Just a reminder, that's your x equals -b over 2a. So negative, our b value is 8 over 2 times our a value is 1. So -8 divided by 2 is -4. So we're going to say x equals -4. I'm going to go ahead and draw that on the graph. What is that, a -4? X equals -4. 1, 2, 3, 4. That's this line right here. So I know that our vertex is going to be somewhere on that axis of symmetry. All right, how do we find the vertex? Well, if you remember, the x value is the negative b over 2a, which we already found, so we already know that the x is a negative 4. Now we just have to plug that back in to the equation, which I can't see anymore. There it is. Alright, so y equals negative 4 squared plus 8 times negative 4 plus 12. Alright, negative 4 squared is a positive 16. 8 times negative 4 is a negative 32 plus 12. 16 minus 32 is negative 16. Negative 16 plus 12 is negative 4. So our vertex has the ordered pair negative 4 comma negative 4. So that is a point that we want to have on our graph. So if we look at our graph again, you go to the left 4 and down 4, and that's where our vertex is. Maybe I'll make that one purple. Okay. So now we keep going. Find the y-intercept. That's the quick one to find. Y-intercept is you just plug in a 0 for your x's, or maybe we've already come to realize that it is the c value. So 0, 12 is the y-intercept. Now on my graph, I believe 0, 12 goes off the graph, but that's okay. I'm going to go ahead and I can fill that in. So my graph goes up to 10, so 11, 12 is going to be right here. Now remember, you can use symmetry to get more points on your graph. Not you can use symmetry, you should. So we notice that our y-intercept is 1, 2, 3, 4 away from the axis of symmetry, so you should go 1, 2, 3, 4 in the other direction and plot its symmetrical point. Alright, so one thing to check, we can tell that our graph is going to be opening up. It's going to look something like this. And our a value is positive, so everything is lining up nicely so far. Alright, so now the new part that we're going to add in. We can find the x-intercepts if we take our equation. Now an x-intercept means you make the y 0, so I'm going to go ahead and make the y 0 right away. So 0 equals x squared plus 8x plus 12. Alright, so we can find our x-intercepts by factoring this. We basically want to solve for x. So we're looking for factors of 12 that add up to 8. That's going to be a 6 and a 2, so x plus 6, x plus 2. Now that it's factored, we go ahead and solve. You set each factor equal to 0. Alright, so we are getting, if you solve the first one for x, you subtract 6, so you get a negative 6, and the other one you get a negative 2. Technically, since it's an intercept, we should write it in as ordered pairs, negative 6, 0, negative 2, 0. Because we're talking about a graph, now we're calling these our x-intercepts. So we're going to plot those points. Negative 6, 0 is 6 to the left and up and down 0. And then the other one was a negative 2, 0. And if we've done this correctly, everything should line up and form a nice parabola, which it looks like it's doing very nicely. So we can go ahead and draw this in. All of our points are symmetrical, it's opening up like it should. And now we have some new points because we know how to solve by factoring. We can find our x-intercepts of our graph.